Hi, welcome back to Statics 1. We're going to talk right now about some basic trigonometric and geometric concepts that you need to excel or succeed in this class. First one is going to be dealing with like sine, cosine, tangent. Okay, it's pretty easy. We're going to jump right to the results, which is showing that. Make sure. Okay, we have a triangle, a right triangle. And we define remember the hypotenuse is that this is going to be x value, this is going to be y value, and then the longer one, the longest distance, opposite the right angle, we're going to call the hypotenuse, which is r. And in this case, of course, we know from Pythagorean rule that x squared plus y squared equals r squared, and we can write r equal to square root of x squared plus y squared. Easy, right? Okay, that's basic elementary math. Now let's jump to trigonometry. And all it is going to be defining these sine theta, cos theta, tan theta are basically ratios between the different dimensions or lengths of the different sides. So if this angle here, I intended this to be a theta. That's a theta, the Greek letter theta. So we can write here is that sine theta equals y over r. Y being opposite theta and r being the hypotenuse. Not a problem. Cos theta equals x over r. Basically, it's the adjacent over the hypotenuse. And then tan theta equals y over x. And it's really sine over cosine. But we'll just write here y over x. So it's basically the opposite, the side opposite the angle divided by the side that's adjacent to the angle. That equals tan x. And so we can always rearrange these. So if we knew the hypotenuse, we wanted to find the other dimensions, we could write that y equals r times sine theta, x equals r times, so y would be equal to r sine theta, x would be equal to r cos theta, basically derived directly from these defining principles. And then the tan theta, you could write it as, for example, x equals, you could write it as y equals x times tan theta. It's also important to think of it, tan theta, essentially it's the slope of this line. So if you have a line if you go 1 in the x direction, you're going to go upward by a value of tan theta. Okay, so that is basically defining sine theta, cosine, tan theta. You want to be able to write these relationships without going through a lot of, you don't want to have to be going from sine theta equals opposite over hypotenuse and then figuring out this. You want to be able to just write these values. So you'd be able to write the opposite equals the hypotenuse times sine theta, adjacent equals hypotenuse times cosine theta. All right, so what do we do if you have the dimensions of a triangle, a right triangle, but you want to find the angles? Instead of using sine, cosine, tangent, we're going to use arcsine, arccosine, arctangent, which is just like the inverse of those other trigonometric functions that we were just talking about. So here's this situation. We have a triangle with an unknown value of theta. We have y here. This is a right, doesn't look like it, but it's a right triangle. Y, x, and r. We already know that y equals r times sine theta, x equals r times cos theta, and y over x. Well, I'm going to write it, I'm going to write it a little differently. Y, now let me write it that way. So we're going to have y over y we're going to have y equals x times tan theta, right? Because tan equals y over x. Okay, and we can invert these. So if we have, actually, okay, so we're going to rewrite sine, cosine, tan as y over r, x over r, and y over x. So we know that we can have y over r equals sine theta, x over r equals cos theta, and y over x equals tan theta. Okay, so what if we know y over r, x over r, or y over x, one of the three, and we want to find theta? Then we can apply the inverse of these functions. When you apply the inverse of arcsine to sine of theta, then you just end up with theta. So we can have here, and I'll write it, I'll put arrows here so we understand what we're doing here. Arrow here. So we're going to have arcsine of y over r equals theta. So why is it theta? Because we did arcsine to both sides, but arcsine of sine is just what, essentially whatever goes in is what you're getting out of it, of the inverse function. All right, in this case, we're going to have arc cosine of x over r equals theta, and arc tan of y over x equals theta. Okay, so we're just taking the arctangent of both sides. We end up with arctan of y over x equals theta, which is the original argument of the tangent function. Okay, you have to be a little bit careful because these functions are defined. These functions are defined for specific values of theta. So our arctangent function is defined for values of theta between 90 and negative 90. So if you put the value in here, you're only going to get these results. If your angle, your actual angle lies outside of that, you're not going to get the right result. So be careful about that. And let's find the other ones so I get them all right. Arcsine is typically done the same way. So it's defined for theta between 90 and negative 90. Theta between negative 90 and 90. And arccosine, and I'm not sure I understand why, is defined for theta values between 0 and 180. So whatever you put in here, x over r, you're always going to get a value out of it between 0 and 180. So if your actual value that was like a negative angle, you're not going to get that result coming out of this. So be a little careful when you apply, oops, I'm out of the screen here. Be careful when you apply these functions that you understand their limitations. Okay, so we already dealt with right triangles. Now we're going to deal with the lengths and angles of other triangles with arbitrary angles. All right, so imagine we have a triangle. And I'll just make this random sort of lengths and angles. And I'll label them. I'm going to label the dimensions of the sides with the capital letters, A, B, and C. So these are the lengths, A, B, and C. All right, and I'm going to label the angles, the opposing each of the legs, with a lowercase of the same letter. So I'll call this one A, lowercase a. Opposite B, we're going to have lowercase b. And opposite C, we're going to have lowercase c. I'll just write it. It's a small letter. So imagine that we have a case where we know A, B, and the angle in between lowercase c. And sometimes my recollection from trigonometry from about many years ago, that's probably called side angle side, right? We have side angle side. We want the opposing length c, and we can use what's called the cosine law. and it says that C is, cosine law is just a function, which is that C equals, C being uppercase C, equals A squared plus B squared. In other words, the square of this length plus the square of that length minus 2AB times cos C. And that C is a lowercase c. That's the angle C. Okay, so we can use this function. Basically, if you know A, B, and C, the angle C, we can use that function to come up with the length C. Now, what if we want these angles B and A? In that case, we're going to apply what's called the sine law. And I'll write that down here, which is the sine law, which is that A, try to do it the same way, equals sine A, B, sine B equals C over sine C. So what it's saying is that the angle, the length of each of the legs divided by the sine of the opposing angle are always equal. So A over sine A equals B over sine B equals C over sine C. So in this case, we have, I'll just mark the known quantities now. Basically, if we knew we started with A, B, and C, so those were known, known, and then we applied this function, we got C. So this one was now known. So now we have these ratios. So we have C, capital C over sine C, which will be known values. So I could write it like this. We could write the sine law for our known and unknown quantities. So I'm going to start with C and C, which are known values. So expressed this way, you have C over sine C, C over sine C. Remember that's C in the, that's the argument of the sine value. That's an angle. This one's a length. Equals B over sine B equals A over sine A. All right? And in this case, this value is known. This one's known. Which one's known? This one's known. That one's known. But you can see how we could just use basic algebra and our arcsin values to come up with lowercase b and lowercase a. All right, so that is our cosine law and our sine law that we're going to use to find the unknown dimensions of our triangle, of arbitrary triangles, not right triangles. There's one more concept. This one's actually quite easy, relating to angles in both parallelograms and triangles. And I'm just going to write that. That'll be the last concept that we're going to deal with today. The last concept I want to talk about are finding angles within triangles, parallelograms, and parallel lines. I'll show you by example rather than telling you what I'm going to do. So first thing you need to know is that if you have a triangle and we're going to label the angles A, B, and C, the angles of the triangle sum up to what? 180. Nobody's here to answer this except me. A plus B plus C equals 180. All right, remember that. The other thing is if you have a parallelogram, and what is a parallelogram? Parallelogram is a four-sided shape with parallel sides. Let's see if I can draw it. Not bad. Okay, so this side is parallel to that side. This length is the same as that length, and this length is always going to be the same as that length. And if you knew one angle, alpha, then you can find all the other angles. And how can you do that? We know that this angle is the same as that angle. This is going to be, we'll call this beta. And the important point is that if you add up all the angles, alpha, beta, they sum to 360. just like if you have a square, right, which is one particular case of a parallelogram, you have like 490 degrees, 4 times 90 is 360. So we have, in this case, 2 alpha plus 2 beta equals 360. So if, for example, you knew alpha but you didn't know beta, you can find beta. And I'll just do some quick math, which is that beta is going to be equal to 1/2 times 360 minus 2 beta. Okay, so just keep that in mind. And the final thing that I want to talk about today is finding angles in this odd kind of situation where you have, imagine you have 2 parallel lines, and then we draw something like this, and someone says to you that you know the value of alpha here, and they say, well, what is beta here? And in fact, there's some tricky problems within our Statics 1 textbook, kind of like this. And so how would we find this? We know that this alpha is the same as this alpha, this angle, which is alpha, is the same as alpha here. And these angles are going to be the same as here. And how you know this? Well, you better go back to your geometry. Thank your geometry teacher. And we know that alpha plus beta equals 180. So then we can say that beta equals 180 minus alpha. Okay, so that's how you know it. So if you're going from an angle, a known angle alpha down here, you want to find beta, you're going to do this thing. This kind of relationship where beta is equal to 180 minus alpha. So that's kind of the final tip for today, but geometry and trigonometry that you're going to need to know to succeed in Statics 1. So we'll see you in class.